Today I'm looking at this Teac TV made by Goldstar. This is a CTM-141 in poor condition, big scratches on the front, on the cabinet, on the tube. I think this one came out of the e-waste. I probably paid a couple of dollars for it just to save it. And I'm glad I did actually, because this is a PC-91 chassis. So, a Goldstar chassis one. These actually have a SCART connector on them. But from the look of the circuit, I did find the circuit online for this one, and it doesn't look like the SCART's hooked up to RGB, but it does have a TDA 3561 chip there, and it can be connected up to RGB. They do have a bit of a weird thing here. I can't get this into AV mode. Got some buttons on the front here, quite a few of them, but only do tuning, colour brightness, etc. Going down the channel numbers doesn't get you to the AV channel, so that's pretty annoying. And yeah, don't have a remote for it, and the remotes always seem to be pretty rare for these Teac sets, but it looks like we can actually put it into AV mode from the SCART socket. So that's something I didn't realise I had on these, but to actually get it into RGB mode we have to do a bit of modification. Just run some caps and resistors like I did with the PC-04 chassis, except we can keep it all inside the TV, and just hook between the chip and the SCART connector. And the other thing we might have to do, it looks like the line, this has got a separate chip in it to switch the AV signals. So this has got composite in and sound in, obviously, and it's also composite and sound out from the tuner. Looks like the ones from the tuner stay pretty much permanently there all the time, but the other ones have to be switched. So the TV, the TDA chip, the input of that has to be switched between the tuner signal in this TV and the AV socket on the outside. And it looks like that chip is, I think it's a TEA 1014 or something in this one. I did have another circuit for this same chassis and it had a different chip, a GC or something made by Goldstar. But they all do the same sort of thing. And the microprocessor in it looks like it pulls a line, I think it's pin 9 on that chip. It has to go up to around somewhere between 9 volts and 12 volts to switch the AV, or to the AV input instead of the tuner. And well, as far as I know, that's the state that it's, because it would be in the default, I would assume, the tuner. And it looks like the microprocessor actually pulls that line down, so from around 12 volts down to 0 volts or thereabouts. And then there's a 10k ohm pull-up resistor on that line. So I'm assuming that the microprocessor is in the pull-down mode for it to be in tuner mode, but it could be the other way around. So we may either have to disconnect that microprocessor pin completely if it's a pull down one. If it's in the low voltage state in tuner mode, that means you basically have to disconnect the microprocessor pin and able to let it float back up to 12 volts and go to AV mode. So we're just going to have a look at this and see what's going on with this pin 8 on the SCART, which also goes to pin 9 of this IC201 TEA 1014. And I would assume that if the line's low, I'm pretty sure it said on the data sheet for that IC that, yeah, when the line's high it switches to AV, but of course I don't know for sure that they've actually got, I should have checked which pins considered the AV in and which pins considered the tuner in, because for all we know, Teac or Goldstar, when they designed this chassis, could have wired them up the other way around or anything. But we do, and according to this one, the other PC-91 I looked at had the pin 9 of the TDA chip pulled to ground for a 75 ohm resistor and no connection to the SCART, whereas this TV seems to have it connected to the SCART. But the strange thing is it has no RGB inputs to that same TDA chip, so I don't know why you would have a line to the back SCART connector that can put it in RGB mode, and yet there's nothing hooked up. That's that one labelled as high speed in, whatever that's supposed to mean, but I can't see what function. I don't think this has got any sort of teletext or anything in it, so I'm not sure what that is actually designed to do, because it basically will just force it into RGB mode with a blank raster, but there won't be any way to get any signal on the screen. But this set does actually seem to run, which is interesting. It's all functional, so this one's just been probably damaged when it was chucked on the scrap heap, or maybe someone got it off a curbside or somewhere, who knows where it was found. Oh, was that already on? Oops, I'm pushing the chassis back, I think. Oh no, it is going. So I should be able to get the pattern generator up on this. I'm not sure if anything's tuned in at all, probably not. So we've just got this display down here, LED display, and it goes from 1 to 39 and keeps going round by the look of it. There's no AV there, which is a bad design really, but that's what they did with a lot of these sets. So without a remote, you couldn't easily get them into AV mode. So often you had to sell them just as a tuner only RF TV, because the remotes, if you had to buy a new one, wouldn't have been worth it. Actually, we've got band select here. How do I know that's band 1, band 3, U? So if we go to band 1, it should be searching through it, I think. But whereabouts in the band it is, who knows? Or is this like the other one where we're going to hold this down? The fact it's flashing indicates it should be tuning, but it looks like I may have to hold it down. The other Goldstar, oh, there we go. Of course, I can turn the volume down. I was going to say it's not letting me turn the volume down, but it is. Now, how do we... that's mute. One of these should set it. I think it's that little arrow either way with an up arrow. I'm not sure what that other arrow is. Was that fine tuning or something? Let's see if it actually stored it on channel 1. It did. So might as well just have a quick look at that and see what the tube's like. It looks like a really sharp tube in it. A little bit of convergence out at the top. Oh yeah, no, we've got a bit of... and on the white it looks a little bit out in the purity. Actually looks alright there though. Yeah, maybe a tiny bit of green. Might have to degauss that. The fact it's been chucked around a bit by the look of it may mean it's got damage to the tube or something. You never know with these things. But you would hope the degausser would have gone and degaussed it as soon as I plugged it in, but whether that was enough... I think that's a bit better. I was pretty sure there's some weird reflections in this place, make it look a little bit off. Yeah, I think that's what it is. It's actually the bench and the light there, so that's probably what most of it was. But yeah, a bit of red out, red's out down the bottom, red's out up the top. You can see just red on that line on the side there. But yeah, so basically a working television. So I thought I'd try the RF input first. Now this should not be a live chassis. Well, it's got a scart on it, so I'd say it's definitely not a live chassis. Tuner sticking out the back, so definitely not. Now to get these chassis out of the cabinet, that cord out, there's one screw right down the front there where the buttons are, with a big plastic washer on it. Well, there's enough light to see that, but you've got to unscrew that. It's basically designed to stop the chassis getting jammed in the back panel, I think, or back cover, and sticking to it, pulling out as you pull the cover off, like some of the Samsung sets are a bit of a problem doing that, because the board was loose in there. And we may have to unplug the degaussing, I think. Oh, that's actually tied up with a cable tie. Does have enough length. I think I'll cut that cable tie off. That should give us a bit more room. Power cord just pulls out the little thing in the back there, and yeah, that's it. And these are still the thicker neck type tube, A34 KCQ12XX. So still haven't gone to the thin neck tubes at this point. These are still somewhere, I guess, early to mid 90s, these ones. Probably still in the early 90s, I think. I've got a feeling the PC-08 chassis may have been very similar to a PC-04. I do remember them being a thing, but I think most of the sets you saw after that were, after the PC-04, were these things. So there, it's got PC-91A. I knew some of these Goldstars had the chassis number written on them. I thought it was the PC-04 did as well, but I couldn't see it anywhere on the one I got. So we've got the SCART connector. See, that's our chip, TDA3561 or TDA3560 POW. SCART, 13 audio out, 26 audio in, 7 blue in, 8 slow switching. Well, 7 isn't the blue RGB in, so I'm not sure what they're talking about there. And where's is this? That's a TDA2579. I think that's our a sync or something, because we've got vertical and horizontal written there. Oh, there it is, TA1014. That's our AV switching IC. And it says audio video up here. So we want the SCART, so it's a pin 8 and pin 16 were the switching ones. So pin 8 should come through a diode, and then we're into that line from the microprocessor. So yeah, which side's even and which side's odd. And then where does it go from there, I guess? So it goes across the board somewhere. Do I see a diode? I see a diode. I should have a diode number here somewhere. It is D201. Yep, that's the one. So there's a little diode right behind the SCART connector around the middle of it. So the other side of that, I'm just going to have a look at the voltage on that, I guess. When we're in normal TV mode. I'm going to have to push the chassis in to get the switch to operate. Yep, we're running. Tuner is as good a ground as any. And on the cathode side of that diode, yeah, we have 0 by the look of it. That's what I would have expected. But that's, so the micro is pulling that down. Now the question is, can we force that voltage up to 12 volts with the microprocessor yanking it down at the same time? Seems a bit of an odd thing. Now that's the micro down here. I think it was pin, was it 31 or 36? I've forgotten now. I guess I can soon measure it across. Where's that diode? That one there should connect to one of these pins. 30, not 31, and it's not 36. Definitely working. 30, 31. I could have sworn it was one of those. Ah, so maybe there is a diode or something isolating it. I better check that part of the circuit again. Yeah, okay, so it's pin 32 of the microprocessor should go through a diode to this other diode. So if we get the probes around the right way, we should measure a diode 3032, and there's our diode forward voltage drop. So what it looks like happens is that a 10k resistor from 12 volts to pin 32, so that the microprocessor can pull that down to ground, and this TEA chip on pin 9, I think it was, won't get any voltage, so it'll just leave the tuner running through. Now if this microprocessor, if we had the remote and told it to go into AV mode, what it would do is let that pin rise, and the 10k resistor would pull the line up to 12 volts, go through a diode to pin 9 on this chip, and it would switch to AV input. Now because there's a diode isolating this microprocessor from that chip, if we shove a voltage in through pin 8 into this chip, we should be able to force the chip on into AV mode. So even just hooking like a 9-volt battery or something to the back of this thing would probably be enough to lift it up, or connecting to a 12-volt supply definitely, but I think this chip, TEA chip, says anywhere from 9 to 12 volts. We'll switch into AV mode, so it could be as simple as actually just putting a 9-volt battery on that line, and we may be able to get the set to switch into AV, but we of course need a ground connection as well. So it looks like we can force that on, and regardless of what the microprocessor is doing, the diode's blocking it, so the voltage can't be pulled to ground by the micro. It doesn't see any voltage because the diode's blocking it. So that all makes perfect sense. So I guess the next thing would be my idea was that maybe these sets, you could basically force them from the outside just with a little battery or something. If you didn't even want to modify one of these sets just to get it into AV mode, we can probably tell it to switch on from the outside if you didn't have a remote. So I'd kind of be interested to see whether we can do that with just a 9-volt battery on a battery snap. because I think that should in theory work. And just with something as simple as that, we may be able to force this set just in a composite input mode. See if this battery's got 9 volts on it. Yep, perfect. So if I hook that up, I'll get rid of that 390 ohm resistor there. I'll put this set back up on its normal position. Let's cut a new bit of carpet for this bench. Power generator out of the way. And so what pins are ground on here? A whole lot of them. So 8, and then 9 is ground by the look of it. Yep. So that's 8, and that's 1, 3, 5, 7, 9. Yeah, the next one's the 5th one, 4th on the top, and 5th on the bottom. If I can connect them, I may need to strip those wires a bit more. It could be that I can force this set into AV mode. Out of tuner mode, come on, switch on. Those switches are pretty annoying, especially when the chassis is a bit loose. Nothing's happening by the look of it. Oh, there we go. So that's a 9 volt battery plugged into the pin 8 and 9. How simple is that? So a kid could have done this quite safely and completely isolated, which is what I was thinking. You could use one of these little, what I was thinking is one of these AV to SCART to composite connections, assuming you can get them apart. It's the next problem. That's one thing I didn't think about. Don't know if there's any screws in these or whether they're sealed up forever. Oh, we've got another fancy metal one here. Does that come apart? Doesn't look like it. Must be a way to get into it. Probably just push together. There's an actual Xbox one. Audio, left, right, video, but I'm not sure whether that goes. I don't think Xbox had a SCART on it, did it? And then why would they make an Xbox one if they didn't have a SCART? And that one's just an in only, which might be the one to pull to bits, since it's less useful than the others. So my first idea was, yeah, could we just get, without doing any modifications to the TV, without even opening it, can we force these things to at least take a composite input? Because it wouldn't be the end of the world if you either just unplug this little module or could flick a battery on and off from the outside. Oh yeah, they just pop open. Look at how convenient is that. So yeah, if I simply hook on to 8 and 9 with the battery, which is here, 4th one there and 5th one there. I'd never realised these sets could be so easily forced into AV mode. Probably could have done something like this, sold something like this with them to sell them as an AV set back in the day, and it would have been worth a lot more and a lot easier to sell to anyone who had a kid or something with a PS1 or whatever, N64 or whatever was back in the day, various consoles. So put the positive on that, negative on 9, probably could connect to this other black wire here or something, it's probably earth as well. But no use messing with the existing cables. I guess if possible. Yep, so they're joined in. Let's pull that out the back. I wonder if I can even get this cover back on with those there. Possibly. At least partially. Yeah, plug's pulled in, of course, as they always do with these SCARTs if you don't get them right in the slot. That's why SCART was such a pain to work with, because they weren't easily hacked into like RCAs and separate connectors. You just plug in what you want and don't want, and nice and easy, whereas SCARTs are all sort of enclosed in these leads and adapters and stuff. So not an easy way to do it. So if I plug this unit in, if I get the plug right around, and it's not going into the socket for some reason. Yeah, we've switched. Now, where's my pattern generator? And which plug? It must be that one. Yeah, there we have it. Nice clean signal there. A little bit messy around the edges, being composite, but yeah, better than that RF. So that's simple enough. So you could actually force one of these TVs into composite mode if you simply hook up a 9-volt battery to pin 8 and 9, and then this will make your composite inputs work. I didn't tighten the audio because I haven't got anything plugged into it. I guess I could try. Could probably plug the other end into something. I'm going to need another lead, I guess. Since I don't have an audio source on this bench. You can probably hear it just by touching on the volume up. Yeah, you can hear me put my finger on the end. That pretty much proves that's working. And I guess we can put it on the other channel. This is only a mono TV, so they're probably joined together or something. That was the other house. Come on, out you come. Yeah, so both the inputs left and right on that adapter are connected into the audio. And now the plugs come out, you little mongrel. Come on. The metal bits come out of the plastic case since I've got it apart. And we're never going to get that out again in a hurry. There we go. So that proved that concept, that you can simply force these in if you had a 9-volt battery with a switch on it, or you could use an external power pack or something. But either way you can. If you've got one of these sets without a remote, it's basically designed to be forced into AV mode by an external voltage. Of course, we could modify something in the TV if we disconnected that microprocessor pin 32. I guess I could do it just to show it, but that'll stop that pulling that line down, and the set will go into AV input mode and just stay in it, which, given RF, there's nothing to plug into RF anymore really, as far as TV channels or anything. That'd be one thing you could do with these sets, just permanently set them to AV input mode. And of course, if we're going to go RGB on this as well, we're going to want it in that mode. So we're either going to have to force it via the SCART plug, or by, should be a diode off that pin somewhere, but there's no reason I can't just find pin 32. Actually, we need the diode in circuit anyway. 3132 is that one. If I can make a decent, if the hole on the circuit board is big enough to make a decent disconnection and no risk of it coming back on, I think that's pretty right. And that's another way you could make one of these TVs into an RGB or composite input for good. I guess I should get my lead back on there. Looks like it's on blank raster. So what I can do is remove that 9-volt lead so I can put this thing back together. Wish I don't even need to use this particular one. I could have used one of the other ones. But let's just take that 9-volt battery snap off altogether, so I can at least clip this thing back and it's not falling to pieces on me. Suck up particular way, must do. Get those sockets back in their thing. So they're just basically clipped together, these things. That's nice and simple, and I've never had any reason to pull one of these apart before. Whoops, it's moved in again. They always seem to move. Yeah, that's got it. So no 9-volt at all. Just plug that straight in there. And plug our video in. And bingo. So that's with that pin 32 disconnected. The microprocessor is no longer telling it to go into tuner mode. Of course, you could just cut the track there or something at pin 32 and wire that to a switch on the back or something, so you can turn pin 32 on and off. I guess would be the ideal if you ever wanted to use RF or tuner again. You could just go back to that. Well, RF does go via tuner, but tuner is in TV reception or something, or any other RF device through there. But at the moment we've got this permanently in AV mode while I've got that pin of the micro disconnected. So now the next thing I've got to do, well, there's nothing else to really do, I don't think. Oh yeah, I do have to say I don't need to do anything to the socket because, well, per se, I can use the switching voltage I've already got and the RGB pins I've already got on my modified lead from the pattern generator. But what I do need to do is connect from the correct pins on here, which are the RGB pins, across to the inputs on this chip, which this is a different pin out to the TDA3562. This is, what is it, 13, 15 and 17. So they're all disconnected on this circuit. Pin 13 goes in the R out, 15 and 17. So I'll just put some different colour lines on this circuit. That's our switching chip that we've just enabled this pin 9 to go high in, because we've disconnected the microprocessor. The other option was to put that voltage in through that diode, but that would mean wiring up some external voltage to the SCART connector, which we also are going to need anyway on pin 16. So of course we could, pin 16 comes in through a 75 ohm resistor into pin 9 of this other IC, the TDA3561, and that tells it to go into RGB mode. That links through these little red lines I'll put here to all the little output stages, red, green and blue, and makes them switch from the internal colour demodulator stuff to the external to pin 13, 15 and 17, which will become our RGB inputs. Like the other chip, this one recommends 0.1 microfarad green caps, or unpolarized caps. I might use these. I've got 0.15s, I don't have any 0.1s that I can find in a hurry. So if I go from those pins, which should all be disconnected on the board, although I'm just looking at this, those, oh, it looks like they're not so disconnected. On that other PCA4 chassis, they were completely disconnected. If I look at 13 here, it actually goes up to a little place to put a capacitor. Then where does it go though? Well, it actually looks like it goes to pin 14, does it? What's pin 14 do? I don't think it should go to there. 13, 14 is that our RGB out to the tube, I think. Yeah, RGB. So we don't want a capacitor across to pin 14, but at least I've got a track hooked up here. 15 goes to C514 here. But the other side of that capacitor, oh, that does go up to the SCART connector, I think. So we might be, and here's another capacitor, which must be the next one, and it comes up through another line. Oh yeah, they're going up to the SCART connector. I'll have to check, I forget which pins were the RGB, but it looks like it's 7, 11, was it 7, 11, 15, could have been. It comes down, I'll have to check this other one. Is that definitely going, comes up here to this capacitor, Oh no, I don't think it is connected to pin 14. I thought it was. Oh, and yeah, and it's got a place to put a resistor as well. So these are basically, yeah, that's 13. I think these are already wired, already got the circuit board pads in place. Shouldn't say wired because they left them out, but I can just actually solder these caps and some, I'll put 68 ohm again since I haven't got 75s. I get a feeling I've got 75 ohm resistors somewhere, but where they are, who knows. I think we used to use them for terminating video or some sort of distribution amps or something. So I'm sure I've got some, but whether I've thrown them out or not, who knows. Be easier to buy some new ones and try and find them. But it looks like we put the capacitor and resistor in each one of these little slots here. So it's, what's it saying? C512, R214, C513, and possibly one of these R215, R213 is probably the one. You got an R215, is that off a C? Is that the next one? But I reckon the resistor number 15, C514. That's actually R215, not 214, but yeah, that's the one. So there's a resistor, and the other resistor on the other side. And yeah, 3 resistors, 3 capacitors, and this thing should be ready to go. The sink will go into where the composite was, and we've just got to switch that pin 16, I think it was. Yeah, 16, which will tell this TDA chip to go to RGB. Again, we could permanently wire that so it's like takes a voltage from the TV here, 5 volts or 12 volts, and just goes through a resistor divider network like I put in that PC-91 chassis. I think it was a 470 ohm and a 180 ohm. No, not a 180. It's a 75 ohm that sets the impedance, which this already has on the circuit board somewhere. So I think it's just a 470 ohm down to that 75 ohm, and we're in business from 5 volts. Oh no, was that from 12 volts? Yeah, it's from 12 volts. 180 ohm from 5 volts, 470 ohm from 12 volts. And I don't think there's any 12 volts or other voltages on that SCART connector, but we could actually use a spare pin on it, I guess, and connect our own 12 volts to it, and then just put a link inside the external SCART plug that automatically switches that across. We could put a link inside that, or a resistor inside the TV to do it, and just make it permanent. You could put a resistor to a switch inside the TV so that you could switch it from RGB to composite. But there must be, I think there was 12 volts on that little switching TEA chip over there. Yeah, well, that pin 9 had the 12 volts come into it, so you could almost go off that if it's permanently in that mode. There might be enough, there's only through a 10k resistor, so there's not much current, but I don't think you really need any current. You just need to lift the logic level up. And one of these other pins, I think pin 13, oh yeah, there it says FT 12 volts coming in through a diode to pin 13 of that chip. That's basically 12 volts, minus the voltage drop of that diode. And we could probably even find the other side of the diode. Is that 204? It is 204, I can see it right there. So we've got D204, we could go from that through a 470 ohm to pin 16, which is what I think I might do. And that should set us to RGB mode, fit our resistors and capacitors. And it's as simple as that. You've got an RGB input set by the look of it. So the first thing to do would basically be to find those unused component pads and just suck the solder off them. So we're ready to put our components in, because all those are sort of, the wave soldering process is just put solder over the holes, but they're all drilled and everything ready to go. C514, so it's pin 15, 17 and 13, which is the one that goes up here to this C512 by the look of it, and R214. So we've got 3 holes for resistors, and I don't even have to look up what the pin out of the RGB pins are on the SCART, because I assume they'd already go there. And now, yeah, it's just a matter of plonking some 3 caps and 3 resistors in there, and I'll solder that 470 ohm across, and we'll see if it works. So to get this board right out and easy to work on, you'd probably need to pull the EHT off, or we could actually cut the cable tie, but these are easy enough to access from the back here. So I've got a C512 hole there. I might even just leave these capacitors sticking up in the air a bit so I can reuse them if I want to. C514, C513. So that's our 3 caps in, and then we've got 3 holes for resistors, and I want 68 in that. I've got some loose ones here, yeah. So these are probably a tad long for those holes because they're made for 1/8 watt resistors. I've got 1/4 watt, so we just need to stand them up a bit, bend the leads so they point up like that. I'll bend one of the leads back round and just poke them in the holes. So it's a wonder they didn't bother making these things with all this, but I guess if no one was going to use it, they weren't being sold with RGB as a feature. I guess the factory gets to keep the cost of those few resistors. I mean, if you're making thousands and thousands, tens, hundreds of thousands of TVs, it adds up in value. So I guess they kept all those components for themselves rather than put them in here, only to have no one ever use them. But given that this all can be switched from external, it would have been nice if they had put them in there ready to go. But I thought one of these TVs was basically made to, one of these Goldstar chassis, to be easily modded. And it's really easy if it's just simply a case of everything's there, but no one's put a few of the parts in. And yeah, the only reason I'm hooking that other resistor across is that's meant to be a voltage coming out of an external source, but most RGB sources since the 80s don't have any sort of switching signal as far as I know. That was a SCART specific thing, so we can always just sort of hardwire it and force it into the RGB mode. And of course you could switch it if you wanted to, if you really want to think you're going to use composite inputs. Like I say, you could actually make different SCART leads up and have one with a link. If we hooked one of these spare pins up to the 12 volts or 5 volts, whatever, but 12 volts is convenient in this set, then it would be a simple case of putting one SCART lead in which happens to go to your RGB device. When you plug that one in, it puts the voltage across through a link, forcing the chip into RGB mode, and then you just unplug that, and when you go to composite and you don't get that voltage across from the composite lead, there's no link in it, and so the TV just reverts back to having no voltage, which means it goes to composite mode. And then I guess would be the ideal. Still a pain because you've got to change the SCART leads, but that was the problem with SCART leads. I guess the other option would be to hang a switch out the back somewhere, because since you're using the same composite lead, if you just want to access the RCA plugs and change them at the other end of the lead rather than get to the back of the TV, then you'd have to have a switch somewhere on the back, or on lead. I guess on that SCART lead you could actually wire it into the other end near the plugs, the RCA plugs. I think they all look alright. And yeah, if you did that, then you could switch it remotely from the other end without having to access the back of the telly. So I think, oh wait, I didn't put my I don't know why I'm even putting a towel underneath this to protect it, because it's that scratched already. I've got to put a 470 ohm resistor from the 12 volts I didn't actually measure it in that other set to see what voltage it came up with, but I guess it'd be a bit easier in this one to do that. But the fact it switched means it must have been somewhere in that voltage range as needed. So let's pin double check that, pin 16 of the SCART, yep. Yeah, 16, 18, 20. But this shows... Is that my imagination, or does that go to a couple of diodes? Looks like it goes to a couple of diodes. Pin 16 on the circuit though. Doesn't go to any diodes. This shows that, oh, that diode's not connected for starters. And that diode could be a link, I guess, or something. And it's going to another diode there. Oh, is this? Because I was looking at the circuit of this thing. It's Teac TV, and I'm sure it was set up wrong, but I'm starting to wonder maybe it is, because it actually had the had pin 8 via a diode connected to pin 16, which I thought seems a bit absurd, because you would always force it into RGB mode every time you put a voltage, or every time the microprocessor even put a voltage on the TEA chip to switch it to AV mode. It would also go to this pin 9 of the TDA chip. 14, 13, 12, 11, 10, that pin 9. Now does that come up to... No, not directly. Now did I see this? That's definitely connected to there, isn't it? Yep. And that's a diode. Now does this other diode here go back to pin... It does, to pin 8. So pin 8 comes through a diode. So it's like they said in the circuit, except there's an extra diode. That doesn't make much sense at all. Or maybe this is not connected to that pin 9. Well, so far it hasn't been connected to pin 9. So there's something else in the circuit that these guys aren't showing. So maybe we can't use this pin 16. So pin 8 goes through a diode to pin 16, well, that which is via a diode, onto this jumper wire, onto another jumper wire. Oh, yeah, this is going down this chip, I think. I thought it went somewhere else. That's not. Is that right? And that comes to there. So it must be pin 9. 7, 8, 9, yep. So they can both turn that into AV mode. What I don't know is how on earth we get to pin 9 of this TDA chip. 14, 13, 12, 11, 10, 9. There is some measurement as if it's connected to that. We've got a resistor here, is it? That's R523, if it even is a resistor. It measures more like a short. Oh, that's so this has been pulled to ground. It's like in the other circuit. Yeah, I don't know what on earth, this circuit for this TV is weird. So what they've done with pin 9, I was going to say, it didn't make an awful lot of sense. Pin 9 comes via, I think it's I forget what it was, a very low, or fairly low resistance. It is a 75 ohm. I was going to say, is it a 75 ohm? It is a 75 ohm to ground. And that's all, oh yeah, okay. That's all it's connected to currently, so it's just pulled to ground. Since I'm not going to go via a SCART connector, if I just go to that resistor pad there, that's our 70, yeah, so I've got to go from here to 12 volts. This R212. Yeah, I thought that circuit must be telling me lies. Yeah, it looks like it's got something soldered in it, but it doesn't. Okay, so forget pin 16 for now. We need to go to that R212 there. R212 to the side of that diode. Yeah, I thought I was gonna check that, and I forgot all about it, but I thought I'll have to look at the TV itself, because there's no way the circuit's correct. Although the circuit's kinda correct, like, but it's not really. So yeah, so they've, yeah, it's different. They showed them joined together, but also joined to pin 9 of the chip, and I thought, well, that can't work, because it would force, every time the TV went to AV, it would force the TDA chip to go to RGB, and you wouldn't get AV at all because it'd be looking for an RGB signal. So I'm going to the 12 volts, which is the anode of the D204, across to what is pin 9, which is currently or initially only connected to ground via a 75 ohm resistor. So once we go through this resistor, that should get us in the correct voltage range of 1 to 3 volts on pin 9, which will force into RGB mode. Oops, I don't actually have the camera on that bit, but I'm up here. We've got the resistor across from D204 that feeds the 12 volts to the TEA AV switching chip. Just because that was a convenient place to get it, I could have gone to one of the pins on this chip, I guess, because that would also have 12 volts. And it's going to this little R212 it's marked as. So if you wanted to modify this set for RGB inputs the normal way with the switching voltage through the SCART, yeah, you just have to put that R212 in and flick this D203 from where it currently is to where D202 should go. And that would feed your voltage coming in through pin 16 through that diode. And, well, the resistor, you just probably put a link there. If you're going to put like your 5 odd volts in, but you could also put a resistor there to drop the voltage, like we're doing in this case if it was a higher voltage, or else you just put a link where R212 is, and that's what a normal SCART connector would have, and then it's up to you to supply the 1 to 3 volts into 75 ohms from there. So that, technically, should be an AV mode, should be an RGB mode, and if I just hook my modified SCART lead up to the pattern generator, which is which one? That one? Sync, that's the one. Yeah, mod RGB. That's the lead I showed before, how to modify it into an RGB lead. Blue, green, red, sync, and I don't need my switching voltage because I haven't hooked that side of things up, so there's no point putting that one in. Okay, power on the pattern generator. Where's the power cord for the TV gone? Oh, still in the PowerPoint. I think that's on. I can't see the display. Oh, here we go. Yeah, so that's an RGB pattern. The lines are super sharp on it now, none of that little colour, weird sort of patterning stuff on the edge. And that's it. She's RGB modded. Very simple. Can we adjust any of the contrast or brightness? Probably not on this one. Look at the way the TDA chip was set up. Oh, you can actually still do the brightness. I thought that was on the little luma input. So if anything, that would be... pretty sure the chroma or colour shouldn't work. Yeah, I would have thought the brightness was just affecting the composite, which is an earlier part of the chip. So they're all different, these sets, by the look of it. But we can do brightness. Almost looks like it's doing contrast rather than brightness, but it does do something. And yeah, real shame this TV's in terrible condition, but at least I could prove that it is possible to do that. If I go to composite, of course, I think we've been stuck in RGB mode. We're not going to get anything, but I'm not on the composite output. Where's the sync line? Yeah, just nothing comes up. Oh, where's that brightness? Absolutely nothing. Not surprising because the chip's forced in. You'd have to put a switch on that little 470 ohm resistor I put in there. I guess I should have a look and see what actual voltage that 470 ohm is dropping things down to, because that was just a guesstimate of the rough resistance needed, just based on the value of the other one, rather than doing any Ohm's law or anything, which was what I should have really done. So you know the exact voltage divider output sort of thing. That was on. Can't really tell this set, it's quite quiet. And the voltage going in the chip is 1.6 volts, so it's a bit on the low side, but it's above 1 volt and below 3 volts. So just using that ground shield as ground. So it's spot on in the range. 470 is a standard resistor value. Maybe a 390 would get it up higher, but it might be too high. Yeah, nice and simple. So for the sake of 3 capacitors and 4 resistors, and disconnecting a pin on the microprocessor, you can convert this TV to a permanent RGB input. I mean, I could find, if the cabinet was okay, I could just find another tube probably for that, possibly even polish that off. They're not actually that deep, but it's a shame because that tube's actually very good condition by the look of it. I think this is another low hours TV, probably why it survived all these years, because someone hardly used it, whereas the high hours versions of these TVs are all getting worn out by the late 90s, so the tubes are already starting to show signs of dying in them then. But yeah, they're probably ones that will run all day every day kind of thing, or certainly many hours a day. But that shows that the PC-91 chassis is very well set up to become an RGB television. Certainly a much better picture than through composite, let alone RF. Yeah, so I just need to find another one of these chassis that's actually in good condition. They did come in a 21-inch version. I think that was it, just the small one and the big one, or 51 centimeter and 34 centimeter, or 14-inch, 14-inch, 21-inch. I did fix up a few of these over the years. A lot of these came in for repairs, usually power supply or horizontal issues. The power switches in them again used to die. I think they were a PREH Prey or something brand of switch. They were very common, like a white looking switch, some with remote contact, some without. They're very common for failing. And I think even these ones, I think the power supply had capacitors that fail. I haven't actually looked at this yet. Oh yeah, this is the one with a little 8-pin chip in it. What is it? A TDA 4605 by the look of it. And yeah, this has got electrolytic capacitors right up hard against resistors and stuff. Very similar design, basically. Looks like it's got a secondary relay like the PC-04 chassis. Same sort of Phillips chip in the colour section. Bit different microprocessor and stuff, but it's probably quite a similar design. It's got an LA chip 7830 for the vertical output. But I wouldn't mind betting this is a very similar design to their earlier chassis. It's just a few things like this. The switch is mounted on the circuit board now. The power switch, that is, along with all the other bits and pieces. And yeah, it's got a secondary relay, which I think occasionally you get dry joints on those. Sometimes the diodes and fusible resistors on the secondary go. I think sometimes you get dry joints that kill the horizontal output transistor, that sort of thing. And yeah, occasionally I think those little TDA chips blow up in the power supplies from time to time. But they weren't too bad a chassis, these things. And yeah, easy to modify to RGB. Okay, one last thing I should check on this TV is the actual yoke wedges, since it is a Korean set. Not sure if the Goldstar were the worst of them, but it's always pays to see what condition they're in. They look pretty good, the bit I can see. Oh, that one really does not want to come out. Usually they come out easier than that. The top one comes out. Yeah, I think they are the dodgy ones, but that's still in pretty reasonable condition. But yeah, definitely those black ones that tend to fail. Probably depends a lot on what sort of conditions they've been stored in. Whoops, how warm they're kept and stuff. they haven't gone oily yet. But yeah, not the best. I'll just poke them back in there for now. I'm not sure what's going to happen to this set, but if I decide to store it any sort of long term, it's probably best to get rid of those out of there. Especially after seeing that Orion one, how bad it was just from being in storage. So it's something to think about. Now that I've seen that, I think I might, any of these TVs that I store, I might just rip the actual yoke wedges out and throw them away. Might have to come up with a new way of making some, maybe even a mould and put some silicon in or something and make some silicon versions. I used to just pull them out of old computer monitors. I was always throwing them away. And they usually had the newer sort in, generally a lot newer. This was sort of later VGA monitors and stuff. And I used to buy a lot of those, and quite a few of them would be unrepairable with the tubes or whatever, or some part you couldn't get, line output transformer or something. And usually just put one back in these colour TVs. One's usually enough if you get the top of the yoke in the right position. That tends to be all it needs normally. But unfortunately I threw out any of those I had left when I shut my business down. So we're going to have to come up with a new replacement, I think. Same with that PC-91 chassis I had. I forgot to actually check them in that, but that would have the same sort of rubber ones, probably even older, so more likely to be starting to go. So I think these things just deteriorate over time, and you don't know when they're going to go. So it's probably best just to turf them in all these sets. At least it protects the yoke then. And yeah, after that other Orion one that dripped all over the board and stuff, they definitely could be a bit of a risk, I think. But anyway, thanks for watching.